Okay. So question number 6. This question is about the energy changes that take place during the chemical reactions. Okay. Nitrogen reacts with oxygen to make nitrogen monoxide. The reaction is endothermic. Okay. So it means that the enthalpy change value would be positive and the energy of reactants is lower than the energy of product as the reaction is endothermic. So when the energy is absorbed or taken in and the product is formed, so product must have higher energy. Okay. Now, draw on the axes provided in figure 6.1. The reaction pathway diagram for this reaction include the labels for axes, reactants, products, enthalpy change of reaction and activation energy. Okay. So if you recall the axes, as I have told you in the last paper, that on axis we are going to either write energy or you can write enthalpy, and on x-axis we are going to write reaction pathway, right? Okay, so we are done with this. Now, reactants. So we have decided that the reactants energy is lower. So we are going to make the reactants, for example, over here, and we will make the products over here. So I'm going to write reactants and products. So see, we are done with this. Now, the enthalpy change of a reaction. So if you recall, the enthalpy change of a reaction is from the reactants till product. So that is the enthalpy change of the reaction. So we are done with this one. Then they ask you the activation energy. So that for the activation energy, we are going to make the arc like this. Okay. And the activation energy is always start from the reactants. So we are going to put the at the highest point. So the arc would be like this. And we are going to label it as a activation energy. If you guys recall, I have told you earlier. Yeah, only the diagram difference between the exo and endothermic and the arrows. These arrows are very important. For endothermic reaction, put the arrow, both the arrows upward. And for the exothermic reaction, this arrow is upward, but for enthalpy change, as reactants are over here and the products are over here. So from reactants to products, we will make this and we will keep the arrow like this for the exothermic reaction. Is this clear to all of you? No, it's not needed. You can just write EA. Sorry. Yeah, there is no need to mention the triangle over here. Yes, Rahim, you can also write the reactants N2 and O2 on the reactant side and at the product side 2 moles of NO. Okay, now part B. Hydrogen reacts with a bromine to make hydrogen bromide. Calculate the enthalpy change for this reaction. Use the bond energies in the table 6.1. Okay, so the bonds which are on the reactant sides are the ones which are broken. So I'm going to represent them with BB. And the bonds which are on the product side, on the right side, are the bonds which are going to be made. So I'm going to write BM. The formula to calculate the enthalpy change with the help of bond energies is going to be the energies involved in bond breaking minus energies involved in bond making. So if you see, there are 2 moles of HBr, so it means the hydrogen bromine bonds are twice. So it means I have to multiply this with the 2, but there is a 1 mole of hydrogen bond and 1 mole of bromine bond. So we are going to keep it as they are. So there are 2 bonds which are broken, the hydrogen bond. So I'm going to write 436 plus 193, because these are the energies for the bonds which are broken, minus the bond which is made is twice of 366. So can anyone calculate it and tell me the answer, please? So, yeah, Rahim, it's minus 103, not 103. Mustafa, Heather, yeah, Rahim, minus 103. Overall answer is yes, Zainab, very good. Ahmed Mustafa, very good. So you have to keep in mind, if you are getting the answer in negative, you will put minus 103. Okay. And we are going to mention it over here, minus 103 kilojoule per mole. Okay. Now, let's move to question number 7. Ethene, butadiene, and butene are alkenes. So see, we know ethene, it's a 2 carbon, so it is going to be CH2 double bond CH2. For butadiene, it's 4 carbon because it's but. So 1-ene means the double bond is between carbon 1 and 2. So it is going to be like this. And for but2ene, it is going to be like this: CH3, CH, double bond, CH, CH3. Okay. The displayed formula of ethene, butadiene, and butadiene are shown in figure 7.1. State the general formula of the homologous series of alkenes. So if you recall, it's CnH2n, right? Yes, very good, Heather. Now, butadiene and but2ene are structural isomers. State the meaning of the term structural isomers. So I think everyone remember it. The compounds having the same molecular formula but different structural formula or different structure. Compounds having same molecular formula but different structural formula are called structural isomers. Is this clear to all of you? Okay. Now, draw the displayed formula for but2ene. So you have to draw the displayed formula, and displayed formula is the one in which all of the bonds are shown. Yes, very good, Rahim. Very good, Heather. Okay. So, but means 4 carbon atom, and 2-ene means that a double bond is between carbon 2 and carbon 3. Yes, so I'm going to draw like this. I'm going to put a double bond over here. Then the carbons which are around the double bond has 3 bonds, so that they are going to make 1 bond only with the hydrogens, and the carbons which are on the board of the terminal has 1 bond only, so they are going to bond with 3 hydrogens. So see, you are getting this formula C4H8. So it's correct. Is this clear to all of you? Okay. Now, butadiene is an unsaturated hydrocarbon. Suggest why butadiene is an unsaturated compound. It is because it has a carbon-carbon double bond, not just double bond, Heather, double bond between carbon. Okay. It contains a double bond between carbon atoms. Is this clear to all of you? Okay. Yes, Moise, and what do you want to ask about the previous part? Okay, Heather. Yes, Shan, what you are asking? Yes, it means that the double bond is between second and third carbon. See, see that it's a butene, right? So but means 4 carbon. Let's suppose, let me do it again. So you can start numbering from either side. For example, if I start numbering from here, So this is carbon 2. So I'm going to put a double bond from carbon 2 like this. And for example, if it was a but1ene, then instead of this, I'm going to put a double bond over here. Now is it clear? So I'm going to put a double bond over here. So the carbons which are now around the double bond have 3 bonds. So they are going to bond with 1 hydrogen. And the carbons which are on the terminal has only 1 bond. So they are going to bond with 3 hydrogens, this one and this one. Now I hope it's understandable to all of you. Okay. Now state why but1ene is a hydrocarbon. So it's very simple. It contains carbon and hydrogen only, right? It contains carbon and hydrogen only. Okay. Now, D part. But1ene reacts with the steam in the presence of a catalyst and reacts with bromine. Draw the structural formula of the product of the reaction with the steam in the presence of a catalyst. So, if you see, that is a but1ene, CH2 double bond CH, CH2, CH3. When it's reacts with the steam in the presence of, uh, catalyst, what will happen? That the double bond turns into single bond and both the carbons, one got a hydrogen and the other one got a OH. And the rest of the structure remains same. Okay, it's not CH2, it's CH3. So this is the answer. So I'm going to draw it over here. CH3, CH, OH, CH2, CH3. One more thing. It's possible that I put a hydrogen over here and a OH over here, right? Yes, what you want to explain, what you want me to explain again, Rahim? So there is a possibility then when it reacts with the steam, we know steam, water turns into hydrogen and hydroxide. So see, we turn this double bond into a single bond. One group bonds over here and one group over here. So we can make it like this, putting H over here and OH over here. So in this way, it becomes CH3. And this CH has a OH, so CHOH and then CH2, CH3. Otherwise, that is also possible when it becomes a single bond. You can put a OH over here and H over here. In either way, it is considered as a correct one. Okay. Now, see over here the next part. Draw the structural formula of the product of the reaction with bromine. So if you recall, when this reacts with the bromine, what will happen? Again, a double bond turns into a single bond. One bromine got bonded with each carbon which had a double bond earlier. So CH2Br, CHBr, CH2, CH3, that will be the structural formula. So these are the addition reactions. Yes, very good, Josefa. So the formula would be CH2Br, CHBr, CH2, CH3. Is this clear? Because you are reacting with the bromine. Bromine is a diatomic, it's Br2, right? Who is saying that is the molecular formula? Molecular formula would be like this. If you see how many carbon, it has 4 carbons. So C4, how many hydrogens? It has 8 hydrogen. And how many bromine? 2 bromine. So this is the molecular formula. That is the structural formula, okay? And the displayed formula is the one in which we show all the bonds. I hope it's clear to all of you. Okay. Now E part 1. Ethene is a covalent substance. Draw dot and cross diagram to show the bonding in the molecule of ethene. Okay. Include only the outer shell electrons of each atom. Okay. So they are talking about ethene. There, the formula of the ethene is C2H4, right? So there is a one carbon, there is another carbon, each carbon bonded to two hydrogens. And we know how many electrons a carbon can share. 4. If you draw its displayed formula, so there is a double bond between the carbon atoms and a single bond between hydrogens and carbon, isn't it? So where is the double bond? You are going to put two pairs of electron. And where there is a single bond, you are going to put one pair of electron. Is this clear to all of you? Okay, so if you will draw this, and after this, when you will draw this dot and cross, it will become very easy for you, because from the number of bonds between the atoms, you are easily able to identify how many pair of electrons we need to share. And see, carbon is in group 4, so it's all of the 4 valence electron are shared. But if the element is from group 5, 6, or 7, so it has a and lone pairs as well. So you have to draw those lone pairs over there in these spaces. Okay. Okay. Next part. Explain why ethene has a low melting point. 1 mark, so you need to write 1 point. So the 1 point is that there are weak intermolecular forces. And you can further write that the simple molecule and weak intermolecular forces. Simple molecule and weak intermolecular forces. Okay. Now, question number 8. This question is about electrolysis. Okay. The table shows some information about the electrolysis of 3 different electrolytes in graphite electrode. Okay. With the names of, you have complete the table 8.1 with the names of the products at each electrode. Okay. We have to write the names of the products. So it's aqueous potassium iodide. So if it's concentrated aqueous potassium iodide, so it means we have a potassium ion. We have a iodide ion. As it's aqueous, so we have a hydrogen ion and we have a hydroxide ion. So as it's concentrated, so iodide ion forms attracted towards anode and form iodine. And at the at cathode, cation would do, yes, very good, it's hydrogen, because we know that the one which is lower in reactivity series would reduce at cathode. So potassium and hydrogen is lower than potassium, so we are going to get hydrogen over here. You guys please give me a minute. Okay, now we have a dilute sulfuric acid. So sulfuric acid has a hydrogen ions, right? Sulfate ions and hydroxide ion. So we know in the presence of sulfate ions, always hydroxide and ion undergo. And whenever the hydroxide undergo at anode, oxygen is formed. So we will write oxygen over here. Yes, 1 minute, Kamar. Okay. And the cation is only a hydrogen ion. So hydrogen ion, when reduces at cathode, it is going to form hydrogen gas. So I'm going to write hydrogen over here. Okay. Now we got molten lead to bromide. So it's a lead to positive ion and a bromide to negative one ion. So in this case, we have one cation and a one anion. So the anion bromide will form bromine, and cation, the lead ion, will form lead metal. Is this clear to all of you? Yes, Kamar, what you didn't understand? Okay. Now, next part. Give two reasons why graphite is a suitable material for which to make electrodes. So if you recall the reason behind it, uh, is first one, that it is unreactive, it is inert, yeah, and very good. It does not conduct, it's a good conductor of electricity. And there is another reason, that it has a very high melting point. That's why it is used for the extraction of aluminium. Good conductor of electricity. Okay. Now, C part. Aluminium is manufactured by the electrolysis of aluminium oxide dissolved in the molten cryolite. Okay. At anode, oxide ions reacts to make oxygen molecule. Construct ionic half equation for this electrode reaction. So see oxide ion. We know oxygen is in group 6, so it has a 2 negative charge. And it reacts to make oxygen molecule. So oxygen molecule is a O2. So it means there must be two oxide ion. Yes, you can just write inert. You can write any two, as I've told you, high melting point, inert, good conductor of electricity. You can write any two out of these three, okay? Okay, so each oxide ion has a two electrons, two more electrons. So when they become oxygen atom, so each one is going to lose two electrons. So in total, 4 electrons are lost. And that's why I'm going to write over here plus 4e negative, which means 4 electrons are removed from two oxides ion. Is this clear to all of you? Okay. Now, question number 9. A sample of a clean, dry air contains 0.0400% carbon dioxide by volume. Okay. Calculate the number of molecules of carbon dioxide in 480 decimeter cube of clean, dry air at room temperature and pressure. Okay. 1 mole of any gas contains 6.02 exponent 23 molecules. So that the 0.02% by volume is carbon dioxide. The total volume of air is 480 decimeter cube. So it means that is the 100% air, right? So from here, we can first make the ratio that 100% air is 480 decimeter cube. So how much of this is 0.04%? So when we got this 0.04%, we got the volume of carbon dioxide. Is this clear to all of you? Yes, what equation you want to be explained? This one. See, they have mentioned that oxide ion reacts to make oxygen molecule. So oxide ion is 2 negative, O2 negative, and it will form O2. So when O2 is formed, there are two atoms, so it must be two oxide ions. And each oxide ion has a 2 negative charge. So it means that each oxide ion has a 2 extra electrons. So when it becomes O2, it will lose 2 electrons, but there are two oxide ions. So in total, 4 electrons are lost. Is this clear, Josefa? No, they didn't ask you, so there is no need to write them. Okay. Okay, now. So if you see over here, 100% is 480 decimeter cube because it is the total volume of air. And in that, the 0.04% is carbon. So I just make the ratio to find how much volume is 0.04%? So X is going to be 0.04 times 480 divided by 100, right? So can anyone tell me the volume? It's 0.192 decimeter cube, and that is the volume of carbon dioxide, right? So we have to convert this volume into number of molecules. So we know we convert every quantity into moles. So if I have to find the moles of carbon dioxide, which formula I can use? That the moles of carbon dioxide is equals to volume of carbon dioxide divided by 24, because this volume is in decimeter cube. So I'm going to divide it with 24 only. So 0.192 divided by 24. Can anybody tell me the answer, please? Okay. Yes, very good. So it is going to be 0.008 or 8.0 exponent minus 3. So these are the moles of carbon dioxide. Now what I need to turn into number of molecules. So the number of molecules means the number of particles. So to find the number of particles, what we will do? We will multiply the number of moles with the Avogadro's number, right? So the number of moles of carbon dioxide is 0.008 multiplied by Avogadro's number, which is 6.02 exponent 23. On multiplying this, you will get the number of molecules. Can anyone tell me the answer? Yes, Rahim, what do you mean? No. Okay. So it is 4.816 exponent 21. Okay, let me check, Rahim. You were saying that it's 7.96. Okay. 0.04 multiplied by 480 divided by 100. It's 0.192 and divided by 24. Yeah, it's exponent positive 21. Yes, you can round it off because it's a very small figure. And if you have to write in three significant figures, it's 0.008 would be fine. Or 8.0 exponent minus 3. Okay. Now B part. Complete combustion of fuel such as gasoline makes carbon dioxide. One of the hydrocarbon in gasoline has the molecular formula C9H20. Write the equation for the complete combustion of C9H20. So C9H20 for a complete combustion, it is going to react with the oxygen, right? And when it do complete combustion, what are the products? Carbon dioxide and water, right? Now there are 9 carbons, so I'm going to put 9 as a coefficient of carbon dioxide. There are 20 hydrogens, so I'm going to put a 10 as a coefficient of water to make the hydrogen equal. Is this clear? Now, if you see, there are 18 oxygens and there are 10 oxygens. So in total, we got 28 oxygen and there are 2 already. So I'm going to put a 14 over here. So 14 times 2 makes it 28. So the oxygens are also balanced. Is this clear to all of you? Okay. Yes, Kamar, it's a combustion equation. So in combustion, when a hydrocarbon reacts with the oxygen, it will form carbon dioxide and water if it's a complete. And if it's an incomplete combustion, we will get carbon monoxide and water. Yes, if it's, yes. Now, C part. Higher levels of atmospheric carbon dioxide leads to increased global warming. Give one adverse effect of a global warming. Yes. Very good, Ahmed. Sea level rises. No, it doesn't low weakens ozone layer. Sea level rises, glacier melts, climate changes. So these can be the answer. Global warming. Yeah, flooding due to the sea level. When the sea level rise, it will cause flooding. Okay. Now, part two, describe how the presence of gases such as carbon dioxide in atmosphere causes global warming. So it's the thing that I have told you, the greenhouse gas effect, that if you recall, Earth absorbs energy from sun, or you can write some energy from sun, and rest reflects back. That carbon dioxide traps this energy, hence it reduces the escape of thermal energy to the space, and as a result the temperature rises and the global warming occurs. Is this clear to all of you? D part, carbon dioxide is removed from the atmosphere by photosynthesis. State the word equation for photosynthesis. So you know, in photosynthesis, there are two reactants. One is carbon dioxide and it reacts with oxygen to form glucose. No, sorry. It reacts with the water. Oxygen is the product of the photosynthesis. So carbon dioxide and water reacts to form glucose, and oxygen is released by the plants due to photosynthesis. Is this clear to all of you? Now, question number 10. Proteins and PET are polymers made by the reaction called condensation polymerization. No, if the examiner asks so, then you have to write it. Otherwise, there is no need to write the states. Okay. The diagram in figure 10.1 shows the structure of the section of a protein. Why it's protein? See, it's an amide link. And if you see, this is going to be the one monomer, the fragment from the one monomer or one repeat unit. Draw the general structure of the amino acid monomer used to make the protein. So if you recall the general structure, as I have told you, there is a carbon, right? And we know carbon forms how many bonds? 4 bonds. So out of these 4 bonds, on one side there is a R group, which can be any carbon chain. There is one side there is a hydrogen, one side there is a carboxylic acid. That's why we write acid in the end, and the other side it has a amino group, NH2. That's why it's called amino. So that is amino acid, the general structure. Is this clear to all of you? Proteins are polyamide. Name one other polyamide. Yes, who can recall one other polyamide? It's very easy. There are two polyamides only. Yes, very good. It's a nylon. Now, PET is a polymer used to make plastic bottles. Okay. Figure 10.2 shows the structure of a PET. State the linkage present in PET. So which linkage is this? Very good, Heather. Very good, Rahim. No, you can't make the box over there. for amino acid because it's the monomer. In this monomer, we can't. Okay, yeah. So it's an ester, right? Okay, now next part. Protein and PET are both made by condensation polymerization. Describe the difference between condensation polymerization and addition polymerization. So if you recall, it's very easy. As we have discussed, in addition, it doesn't matter. You can write one group on either side. If you are drawing the carboxylic acid on left, draw amine group on right. Okay. Yeah. So yes, very good, Rahim. In addition polymerization, only one product is formed from the joining of monomers. Okay. In condensation polymerization, monomers join to form polymer and a small molecule such as HCl or water is formed. Is this clear to all of you? Yes, is it clear? Okay. Now, describe two environmental challenges caused by the disposal of plastics such as PET. Yes, landfill sites obviously may fill up, and on burning it causes toxic gases. And if we accumulate in ocean, so there will be a pollution in ocean as well. So toxic gases produce on burning. Yeah, the aquatic life is harmed due to the accumulation in ocean. You can write that one as well. Aquatic life gets harmed due to accumulation of plastics in ocean. Yeah, that can be answer as well, Shamir, because landfill sites may fill up, so we need more landfill sites. So we are done with this paper, and tomorrow we have our next class, and in that we are going to start a new paper, inshallah. Okay. So see you guys in the next class. Take care, everyone. Allah Hafiz.